Today we're going to talk about roots and radical expressions. First, finding the nth root. If a to the nth power equals b, a and b are real numbers, and n is a positive integer, then a is the nth root of b. To put this in terms that are easier to understand, if we have 2 to the third power equals 8, a and b, 2 and 8, are real numbers, and n, 3, is a positive integer. So 2 is the cubed root of 8. Here are some general rules to keep you on track. If n is odd, then there's one real root. If the radicand is positive, the root will be positive. If the radicand is negative, the root will be negative. If n is even and the radicand is positive, then there are two real roots. You will have plus or minus as part of your answer. If n is even and the radicand is negative, then there are no real roots. You will still have plus or minus as your answer, but there will be an I as well. Since I is included, none of the roots are real. They are all imaginary.
What is a radicand?
Well, let's say you have a to the n equals b. Another way to write that is the nth root of b equals a. The symbol itself is called the radical sign. The number underneath the radical is the radicand. The little number above the radical sign is the index. It tells you what root you need to take. Your answer is your root. Now let's do some examples. Here we need to find the square roots and identify the real roots. We'll start with finding the square root of -1. As we know from now in chapter 4, the square root of -1 is equal to I. Make sure, because it's an even root, that we write plus or minus. However, since our answer has an imaginary unit in it, there are no real roots. Make sure you identify that. The next one is 36 over 121. When we take the square root, laws of radicals allow us to take the square root of 36 over the square root of 121. The square root of 36 is 6, and the square root of 121 is 11. Again, make sure you write plus or minus. For the last one, this is a little more difficult because it's a decimal. Let's start by converting this to a fraction. 0.01 is the same as 1 over 100. That's easier to take the square root of. Again, we can break it up. The square root of 1 is 1, and the square root of 100 is 10, giving us plus or minus 10. Now let's find some cubed roots. When you find the cubed root of a number, we need to find a number that will multiply times itself again to give us the radicand. Here, for 0.008, it is again easier to convert to a fraction first. We will get 8 over 1,000. Then, when we take the cubed root, we're only finding the cubed root of 8, and then the cubed root of 1,000. The cubed root of 8, we saw in an earlier example, is 2, and the cubed root of 1,000 is 10. We can simplify this again to give us 1 over 5. Your answer will be positive because the radicand is positive. Moving to -1,000. To find the cubed root of -1,000, we need to figure out what number times itself will give us -1,000. That will give us -10. Again, the answer is negative because the radicand is negative. For our last example, break it up again. Cubed root of 1 over the cubed root of 27. The cubed root of 1 is 1, and the cubed root of 27 is 3. Our answer is positive because the radicand is positive. Now let's find the root when there are variables involved. For the square root of 81 x to the 4th, we first take the square root of 81. That will give us plus or minus 9. X to the 4th is x times x times x times x. We need to take those out in groups of 2. We end up with 2 groups, so we have x squared. remember to put plus or minus because you took the even root. For the cubed root of a to the 12th, b to the 15th, it's very similar. However, here's a shortcut. Whenever you have an exponent, try dividing by the index. Here we would have a to the 12th divided by 3 and b to the 15th divided by 3. 12 divided by 3 would give us 4, and 15 divided by 3 would give us 5, giving us an answer of a to the 4th, b to the 5th. Now it's your turn. Try doing some of these. Feel free to ask me about them tomorrow during class.